Hello and welcome to the Titus Timeout Podcast. I'm Jenny Abney-Civy, and today we're going to talk about what happens when airstreams collide. I've mentioned before that catalog data are taken under ideal conditions. Throw tests are performed with a single diffuser in the center of a test room, but in reality, diffusers are installed in ceilings with walls, lights, and other diffusers, or other things that may affect the airflow pattern. So if you remember back in the throw podcast, when the air leaves the diffuser, a low pressure zone is created that causes the diffuser to be pulled towards the ceiling. Remember, this is the Coanda effect. So let's start with the diffuser in the room. The air pattern will travel along the ceiling until the velocity slows to about 75 feet per minute. Let's make a little more room here. Okay, so at this point, the weight of the air, we're assuming it's in cooling, will overcome the momentum and you'll lose the surface effect. At this point, the airflow will detach from the ceiling. Once it detaches from the ceiling, it'll start to slow down quickly, and so T50 will be shorter than the isothermal catalog data. This is unless it runs into a wall or another diffuser's airflow. So let's look at what happens then. So let's say the diffuser is close to a wall. The air pattern is going to go down the wall. If it hits the wall at greater than 100 feet per minute, this will affect the throw so that the cooling T50, the 50 foot per minute cooling throw, will be the same as the cataloged isothermal T50. If it hits the wall at a slower velocity, it will still have the shortened throw like the other side of this drawing. Let's start a new picture here. Now let's say we have two diffusers side by side in Earth space. What happens when the airflow between the two diffusers collide? Well, pretty much the same thing that happens when the airflow hits the wall. If the velocity that they collide at is greater than 100 feet per minute, then the cooling T50, the 50 foot per minute throw, will be the same as the cataloged isothermal T50. Okay, so now let's look at what happens when there's an obstruction in the way of an airflow pattern. Let's draw another diffuser here. And now let's say that there's a wood beam or some architectural detail in the ceiling right here. So this is probably like half the restaurants I've ever been to. What's the air going to do when it runs into this obstruction? If the angle from the edge of the diffuser kicker to the bottom of the obstruction is greater than 15 degrees, then the air will hit it and drop. If it's less than 15 degrees, the air will continue past it in its normal air pattern. So the important thing here is the 15 degrees. Anything greater than that will cause the air to drop. Different diffusers work differently with obstructions. Ceiling-dependent diffusers don't work as well as ceiling-independent diffusers. If you recall from the ceiling-dependent, ceiling-independent podcast, a ceiling-independent diffuser creates the low-pressure Coanda zone inside the diffuser, and a ceiling-dependent diffuser needs the ceiling to create this low-pressure zone. So that covers what happens when airstreams collide. Don't forget to subscribe to our YouTube channel, and thanks for taking a time out with us.